AP Chemistry virtual lesson. My name is Michael Faribaugh, and I teach AP
Alright, can you hear me again? It seems like I'm having some minor technical difficulty with OBS, because apparently the desktop audio didn't work. Were you able to hear the gentleman on the screen at any point? Okay, so you were able to hear him. Alright, so if I leave that open. Um, Basically, the first couple of minutes of the video they sent out today, they he goes into detail as to how to use the AP site. I'm going to highly recommend that to all of you. If you go through this, I'll just let him talk here in a moment, but basically what he shows you is there's some really great practice questions, to which I've been referring as green bullet questions or green target questions. Let him talk for a minute.
Chemistry at Albemarle High School in Charlottesville, Virginia. The focus of the lesson today, as well as the lessons all of this week, is to the College Board website. You can log in at myap.collegeboard.org, and then once you log in, you can take a look at AP Classroom. So when you see your classes in AP Classroom, while your teachers may assign specific practice problems for you all to do, there are optional practice problems for you all to click on and take. So I want to just remind you about that. So if you log in and you click on AP Classroom, you will see a progress tab, and at the top on the far left it says click here for optional student practice. You will also see a link to all of the AP live classes, so you can click on that to access the YouTube channel. If you click on the optional student practice, then you should see a variety of free response questions, and again they'll be labeled, and you can click on any one of them. So when you click on that particular, to begin the question, the FRQ, the free response question, then you can actually read the question, enter your response in the box, and then here's an interesting thing you can do for these optional AP practice questions. You can click submit, and once you click the submit button, it's going to respond. You say yes, but then a screen will come up saying, do you want to submit now, or would you like to review how this question might be scored on the AP exam? So you can actually say, click yes, review, to see the scoring guidelines. Now, once you look through the scoring guidelines, then you can decide to modify your answer. And then when you click submit, you would say, okay, I've already reviewed, click submit, and then no, submit now. And then your teacher will have access to that question you submitted. So again, those are good practice problems. Okay, so again, you would go to log in. That's myap.collegeboard.org. Click on AP Classroom. Click on the optional student practice problems. Then you can work on that. All right, so for today's lesson, I'm going to give you several AP practice.
Okay, so that just basically, they're really nice because they're explicated exactly the way in which they're going to be graded on the AP exam. Same thing goes with what the rest of this video is that they pushed out today. What he does for the next hour is go through 3 problems, but the trick is he gives you the problem, and then he strongly suggests you pause the video and perform the problem, and then come back and let him go through and explicate, because he goes through a very nice job of working through the entire problem. So worth your time. I'm trying to get enough resources out that everybody has what they need to succeed, but it's really tough from, where I am here at my house and you're at your house. I mean, I was hoping this would be a more effective means of communication, but no guarantees. I will say, if you've never used OBS software, it rocks. It's free software. I can play around and edit. I could even show you my face, but that's okay. I mean, ideally, we could throw up a problem of some sort and work it, if that interests you. If you'd rather just, you know, check in today and then try it another time, you're welcome to do that. What do you guys think? Right now, I think I've got Andrew and Aiden on. Radio silence. Okay. Like I said, you're going to get about a 10 to 15 second delay. I'm not sure why we got such a major delay. I'm still playing around with that. Alright, let me kill the screen mic. Alright, let me grab something. Okay, FRQ. We were supposed to get the 2020 FRQs out this weekend, but they didn't come. So we're still waiting. AP Central has been inconsistent, and it's frustrating, but I'll just see. Now, this was released in 2020. Okay. I've got to be careful. Oh, this is the one with the preview stamp of it. Give me a minute. Had it queued up, but then got the wrong one. Apologies. This is not a well-oiled machine yet. Hopefully both have at least a periodic table and our green sheets available. If you don't, you might want to pull them up online. I think, did I put a reference into where you could find those or not? Let's see, that's a drawing one, which they're not going to make you do. Okay, simple lead-off question. See what you can do. Let me see if I can get A and B on the screen at the same time. See what you can do with A and B. Yeah, okay, let me... it says I haven't provided a reference. Let me see what I can pull up. But if you guys want to try A and B, I will find an online site where you can quickly get the green sheets from this year. Is that large enough you can read it? Okay. Try those those two while I get something together here. Okay, real quickly, in our exam review site, I put in a PDF with the reference sheets for this year. It should have the equation, it should have the periodic table and both of the green sheets. There's that. Just making sure it works. Okay, so that's good. There, it's back. Sorry. Okay, you guys finished with the first two? Okay, we'll wait. No rush. Okay, we can wait. How about you, Aiden? You in? Okay. So let's see what we got. First one. Which one? Preferences. Which one do you like? Left or right? Oh, sorry, didn't read it effectively. Okay, so let's see, looking at this one, octet, 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 and obviously hydrogen doesn't, octet, octet, octet. So it comes down to formal charge, and that's what they asked you to do, so that's pretty straightforward. N is going to be +1, oxygen is going to be -1. Either way, the formal charge should come out to 0. Let's check that. So if I look at, let me make this just a tad bigger. Okay, so if we look at the right one, double. That's got 1, 2, 3, 4, 5. Carbon has 5, should have 4, so it's -1. 1, 2, 3, 4 has 4, should have 5, +1. 1, 2, 3, 4, 5, 6. 6 and 6 is good. This is the big problem with the right-handed one, because if the carbon is -1, that says that it's more electronegative than nitrogen or oxygen, and obviously that's not so. Because if you look on the periodic table, we're talking, carbon, nitrogen, oxygen, fluorine, and this is way less electronegative compared to oxygen, 2.5, excuse me, and nitrogen, which is 3.0. So that would be a real problem for that to be -1. But in both cases, they definitely still have to, the formal charges have to come out to 0 on both of them, because the overall molecule isn't charged. Make sense? Okay, let me show you how they would have scored B. Right. 2017 IPE, that's what we're using. What question were we on? Oh, sorry. Oh, that's the actual. Okay, hold on. Where's the scoring guide for the 2017? Oh, bloody hell! All right, I don't have it, so let me just talk it through. So, using the Lewis dot structure in the isotope to determine the delta H of one forming from the other, and since it's 1 to 1, we've got an HC triple bond N, single bond O. Don't have to worry about the electrons, the free electrons. H, N, double C, double O. All right. Nothing stays the same in either of these that I can see. So we have to break all the bonds of fulminic and make all the bonds of isocyanic. So we're going to break a CH, which is 413. We're going to break a C triple bond N, which is 891. And we're going to break an N single bond O, which is 201. And we're going to make an NH, which is 391. We're going to make a C double bond N, which is 615. And we're going to make a C double bond O, which is 745. So I think that's all there really is to that part, because then you just sum it up. This is going to be input energy positive. This is going to be put out, because then you're forming these bonds, so it's all barf. And I could real quickly get my calculator and we can see what we get. And now, since I'm on about a 10-second delay, does that make sense? $15.05. $17.51. So 246. Oh, I agree. All right, so let's go back to this. Let's look at the next bit. Should be able to see, let me see if it flips over for the problem itself. Nope. Okay, so this next bit, try C and D. Actually, no, stop. Don't waste your time. That's an entropy problem. And entropy is not going to be on the exam. Skip over. This is worth your time. Because even though it's a pH problem, which is in section 8, it's still going to be able, you should still be able to base on the pH determine changing concentration H's, OH's. Because that's from chapter 4. So try this bit. Okay, so we're both at the point where we're done enough. So, okay, let me see here. Desk and screen. There we go. Alright, so part E1 just says how did they get the proposed rate law. So what I'm thinking very simply is I'm looking and I've got, okay, at 5 it's 0.707, at 15 it's 0.35, at 25 it's 0.17. Now I see that as half. Sorry, it's popping up. Of course, just as easy to look at 0, 10, and 20 and see that it's halving each time. So if it's halving each time, we're looking at a first order rate law. So I could just as easily have done the whole thing based on 0, 10, and 20, so I now know that it is a 10-hour half-life. Using the proposed rate law and the student's results, determine the value for K. Alright, so let us see here. We've got rate equals K, concentration of whatever that monstrosity is. Some sort of cobalt amide, or no, carbon monoxide amide, I don't know. Did they give a name for that monstrosity? Doesn't matter. Urea. Alright, so what do we have? We know that it is a first order, so first order is going to be linear when it is natural log. So we've got natural log at some point equals the slope of the line. Do we have a slope? Can we find a slope? Yes, we can, because we've got time and concentration. So, alright, I'm kind of all over scattershot here. Let me get organized. Alright, so first order. It's going to be a natural log problem, but interesting. You would need a calculator for this one, which we'll have. You can find the natural logs of all those things, yes. So we should be able to determine the line with time down here and natural log here. Yes, this is not a short problem. So if we take the natural log of, let's see, natural log 0.1 is negative 2.3, negative 2.3, where that's at, and that's at time 0. So we've got a negative 2.3 and time 0, and then we've got natural log of 0.05, it's negative 2.99, and a time of 10 hours. That's all we need. We don't need to draw any more than that, I think. So now we go back to what I was saying. Natural log x equals the slope. I mean, it's y equals mx plus b equals k. Slope, yes, plus. Why am I having a brain fart? I have not been at school enough. I am tired. Yeah, negative kt. Negative kt, natural log of concentration x prime. Okay, did that help? Because that now we've got everything we need, because we've got the natural log of x is, say, negative 2.99. K, we don't know. Time was 10 hours. And then the natural log of this is negative 2.3. We should be able to do from there, yes? Yeah. No, I know. That's the problem. We've got so many. Drew says he forgot about the integrated rate laws. I forget we're videotaping, but they're not going to be able to see the comments. Yeah, the problem is we've got so many things in play out there that we need to refresh our memory on a multitude of different things. For this one, we know that the natural log is going to be linear. Why? Because we notice that in the problem, if I go back to the problem, wrong one. When we go back to the problem, you see that there's a half-life and it's a very specific half-life, and it's halving every 10 hours, and so we can say that it's a first-order reaction. That's the sort of nasty thing that they can do to you, but once you get that, and then you figure out the natural log any 2 points, since it's linear, you should be able to plug those 2 points into the rate law equation. And so if we go here, then it's just a straight up solve for K. Once you've got K, I believe all they asked you to do was they asked you to determine the rate law with the value of the constant. Now you'd have to be careful with the units, because the rate of change in concentration, just molarity per time. Rate law, rate law, rate law. Okay. Did that help? Sorry, I'm a little brain damaged. Okay. And for the last one, all I would do is I would vary it. I would just set up some sort of reaction where I varied it over time. Tried pH 13 and then, yeah, I'd try pH 13, then pH 12, pH 11. Or instead of doing it that way, I would probably go something like this. Instead of saying it's changing the pH, I would simply say the concentration of OH is this. Yeah, hold on. The concentration of OH is this. And so I would go through and say what was it? pH 13, so it was 0.1, maybe 0.2, 0.3, 0.4, and then, but keeping the concentration of the urea the same. Now, for rate, a question was posed, units with K being a little weird though, could you run through them? What's my memory telling me? Because, again, I'm being very candid with you. I'm running on limited sleep today, so I'm a little off. So I'm just going to pull out the text real quickly and make sure I don't lead you astray. I apologize, but I'll just be honest, I'm out there someplace. So with the rate of change, first order reaction, okay, yeah, I made sure I was right. Let me zoom in on this. You still can't see that. All right, but I'll point at it anyhow. Okay, so natural log does not have a unit. Therefore, we're looking at 1 over time as far as our slope. So it's a per second. If we were 0th order, then it would be linear and it would be molarity per second. But in this case, because we're in a natural log situation, I believe everything I've ever been told, natural logs are unitless. Therefore, it's just in per second. Does that sound right? Apologies that I'm a little scattershot right now. Too many other things going on. Yeah, and so in this case it would be per hour. I was just citing the book, thank you. So it would be per hours, or 1 over hours would be the unit. And the big thing that I don't want you to forget is I want you to carefully remember that this is a negative so that it works out. Because if you forget that negative, all goes kerflooey. Even though these are both negatives because we're taking the natural log here, just make sure you work it through carefully to get the right answer. So just out of curiosity, negative 2.99, plus 2.3 divided by 10. I'm thinking it's negative 0.069 is equal to K, so that's 1 over hours. And then the actual rate law is rate equals negative 0.069 per hours times the concentration of, that's a large, concentration of urea. And is that off screen? No, you can see that. Alright. Okay. Hopefully that was a little bit helpful. I would strongly suggest you go to the practice problems that they're giving online. I also would strongly suggest you use the live streams that they're putting out, even though I don't see any reason to waste your time getting up at 10 specifically to watch the live things that are coming out from the AP folks. Yes, thank you. You are correct. So that's negative K, so that's positive. Thank you. I just got corrected because this is negative K equals negative this, therefore it turns out to be a positive. Thank you for catching that. That would have confused folks. No, you're absolutely right. Like I said, I'm a little off today and I apologize. So what I'm thinking about doing is pushing out a problem, and then I'll come in with the opportunity to answer questions. Probably, since there's only a few people coming in, let's try this again tomorrow, see if more people come in, and then we'll just keep trying it for a couple days, and if we only get a few, we'll just do it every other day. So hopefully that was helpful, at least a little bit once we got moving. Anybody have any last minute questions? All two of us. It was mentioned that I should have announced the stream more in advance. I thought I had been pushing out announcements on that earlier, but maybe I didn't. I thought it was in my updates. Could be wrong. But I will shout it again soon. Yeah, the trouble is my updates are so freaking long that things might disappear. Okay. Comment made, won't make the stream every day because of all the videos assigned on top of the College Board review. So why don't I just plan to do Monday, Wednesday, Friday sort of thing? Alright, so let's close this out. Thank you all for coming. I'll push out something today before I leave the computer that'll give you guys something on which to work, and then you can come in and we will check through it, and that'll be a much more efficient use of time rather than simply sitting here listen to me talk or not. Alright, wish you all well.